Today we're going to be talking about blockchain technology, something I really don't understand too well. I'm joined at the table by Nik Chimino. Nik, welcome to the table.
Thank you, Nigel. I'm excited to be here today.
It's good to see you here. We had a little chat before we started the show, talking about blockchain technology. Nik explained it in an incredibly simple way, and I still don't understand it. Nik, why don't you give us a brief overview first about what is blockchain technology? Sort of like, you know, the 1,000-foot look.
Sure, absolutely. Blockchain technology is a distributed ledger. That's how everyone says that. And so we really have to dig into what's a ledger. And it's just like a bank account where you're tracking a journal, where you're tracking transactions. Money comes in and your balance goes down. If I have $100 and I spend one, or I send it out to somebody else, I have 99 left. So that's my ledger. And it's really kind of, you can think of it as a state machine. That's what they would call this in the computer programming. And state is just remembering something, almost like data or a database, and you're keeping track of that. Distributed means it's all over the world, or it can be run from anywhere. A whole bunch of people can participate. And by being distributed, we can track balances that people have all over the world, and anybody can join, which makes it very hard for anybody to take away or to terminate, because anybody can run it, and it uses the internet. So it's extremely hard for anyone to just turn it off. If there's enough people who believe in it and support it, and they're running what they call nodes, that's these little blockchain computers. There's really a program on a computer. When you're running a blockchain node, anybody can do that, and they can contribute to the network.
So what sort of information would people be contributing?
I have to run, if I wanted to run a node, I'm using my computer, I'm using my electricity, and I have to pay for those things. Mm-hmm. So as what they would say as a miner, I would be the one who is getting paid to do that processing. This is why miners are rewarded, because I'm going to verify all the transactions that come in. I'm going to put them into this state machine, and it will track that information, and I need to get paid for that because I use my hardware.
Okay, now, you mentioned miners. For myself, and for probably most people out there, miners are someone that go underground, dig up coal or gold or silver or whatever. In this particular context, what does mining or miner mean?
Miner is somebody who's solving a really hard math problem. And when I first learned about blockchain, that didn't sit well with me. What's the math problem, and how do we understand that? And there's this hashing algorithm that they use. It's called SHA-256, which means that we're working with 256 bits of information, and it's really just one big number. But the SHA, it has a high amount of entropy, and it's non-predictable. We've never had a collision. So what does all that mean? What that means is that every single piece of information that you put into this algorithm generates a new and unique number. And just to put some perspective on that, that number represents more atoms than there are in the universe. Mm-hmm. So picking one of those numbers is just absolutely unheard of. It's never happened. Nobody's been able to figure out the number or fake it.
Right, and I should imagine it's sort of like millions of years to try and crack it.
That's right, exactly.
Okay, now of course SHA-256 is pretty much what they use now for all password generation. So even if you put in sort of like a 7-letter name or even a 10-letter name, ironically it all ends up as this one great big massive number.
Right.
And if memory serves me well, it's also alphanumerical.
Yeah, it can be.
Is it hexadecimal?
It's hexadecimal. It's really binary, but yeah, they represent it as hexadecimal.
Okay.
Generally.
Hexadecimal is the way that computers count rather than us humans. And it uses base 8, if memory serves me well.
Yeah, base 2, yeah.
Yeah. Good. So, blockchain technology. Give us a bit of an example, a down-to-earth example of where this would come in handy. Let's say that we have a factory manufacturing a candy bar. How do they track it through using this sort of technology?
So, we can use the blockchain to do a lot more than just cryptocurrencies. That's what we keep hearing about, is cryptocurrencies and all the financial stuff. Whether cryptocurrencies hold up or not, we don't know. I can see that working because, as we said earlier, somebody's got to pay for me to run a node.
Yeah.
But when we talk about blockchain technology and just distributed state, if me and you wanted to run a company and we wanted to track our assets, we could each be in different parts of the world running this program, our blockchain nodes. They could be communicating to each other, and as I'm sending out this product, you would get that update, and your information on your local computer would be able to see that. And if anybody else wanted to join in our network, they can keep getting that updated state and they can contribute. But they can only contribute if we give them permission and allow them into the blockchain, because me and you can verify who is sending in the information.
Okay, I've got it. Back in the 80s, when I was in computer-aided design, they had devised, the software that we were using, they had devised a system by Intergraph where you could actually have 4 or 5 workstations all talking through a central database. So if I'm designing the printed circuit board, but the mechanical engineer says, oops, we forgot this mounting hole, he could change the mounting hole, and immediately I can see that I've got an IC sitting right on top of that blasted mounting hole that he forgot. Is that blockchain?
That's a beautiful analogy. The only difference there is instead of having one database, everybody has their own copy of the database. And it's also verifiable. So when that change came in, he would have had to have signed that with his 256-bit private key.
Yep.
And he's the only one in the world that should have that. He should never show that to anybody. And when that person signs that transaction, now you can verify it, I can verify it, and each of us can add it to our own database.
Okay. Let's talk a little bit. You mentioned cryptocurrency. Another area that I know really little about, because I don't see how you can have a currency based on nothing. To me, that makes no sense whatsoever. But I'm old school. What do I know? So describe a little bit, and also describe what's the mining aspect. How does that work? Because you said earlier about trying to solve a very complex mathematical formula. Where did that come from?
Yeah, absolutely. Yeah, so the SHA-256 algorithm that we were talking about earlier, I did leave out one part on the end of that, and that is that now, because it has high entropy, you have this input that's going to go into the SHA algorithm. Mm-hmm. What is that input? Let's start there. The input to the SHA algorithm is all the transactions that people have sent in. They sign them with their private key, which is also 256 bits.
Yeah.
When they do that, I can verify that they signed it, because you have both your private key and your public key. Mm-hmm. And with the public, it's really a public address. With the public address, once they sign it, I can run it through a mathematical process that will tell me that this is the person who signed it. And I could send them money and we can interact. I don't know who they are, but because they have that hidden private key, now I can figure out who that person is, and I can send them information, or I can verify that they've signed things. Now, let's say now we're talking about, I have all these transactions from all these people around the world, and I want to put them into the blockchain. So I'm a miner. I have to hash all of those transactions that I verified. So I verified them, and now I'm going to lock them into the blockchain. I'm going to say this is official, and I want to broadcast this out to everyone.
So basically, you're giving it the stamp of approval.
Exactly.
Okay.
That's exactly right. Now, to do that, I have to run this. I take all those transactions, and the trick is I add a number. They call it a nonce. And that nonce...
Sorry, called it a...
Nonce. N-O-N-C-E.
Okay.
And nonce is just, we can start at 0, and we can go up by 1, 2, 3, and we keep trying that to see if our hash comes out with the first digits being all zeros. You could do 10 digits, mm-hmm. You could do 5 digits, and we can control the difficulty based off of how many zeros that the protocol is saying. So this is why it's such a hard math problem, because nobody can predict the output. So you have to try them over and over. And this is why the miners are doing millions of hashes per second. They're trying to figure out the magic nonce, because on Bitcoin right now, it's something like 6.25 Bitcoin at $20,000 a pop. It's a lot of money you get paid
Yes.
for finding that nonce, and that happens every 15 minutes. So there's a lot of money being made by these miners who solve that problem. But then all those transactions, once somebody in the world finds that magic nonce, that all those transactions are allowed to go on the blockchain forever. And then now you've solved the problem, you get your mining reward, and this is how it is protected too. The system, everyone around the world can verify it.
Right.
Nobody can predict it, but everyone can verify it because they can all send out my nonce and that they all had the transactions to start with. So now they can prove that I solved it, and because I signed that, all that money comes to me, everyone agrees on it, and then we move on to the next set of transactions.
Okay. See, you used the word money, and I'm still having trouble correlating the word money in here because it's all based on, well, nothing.
That's right. Yeah. Where does the money come in, right?
Where does the money aspect come in?
Yeah, and that is a very, very good observation. The money really is just like a stock in a stock market. It's only what people are willing to pay. There really is no backing, but when we look at financial systems today, they're moving assets, real estate, deeds, all of these things. It's very expensive. You have to have people either physically move these things, or you have to pay people to be involved. You need notaries. These are the things that can be all automated. So what the financial system is starting to observe is that they can reduce their cost to transact significantly by using blockchain technology.
Okay.
By doing these kinds of things and integrating this programmable money into their systems, it's creating value just by necessity, that you would want that. So it's all about, what do you believe? Do you believe that this technology can come in and transplant, supplant a lot of these older technologies and do so in a more efficient way? If you believe that, and people will start paying to operate the network, that's what you're doing is really, and that's why we see they have what they call the Bitcoin halving. And what this means is, instead of getting 6.25 Bitcoin per block, you're now going to get 3.125. They're going to cut that reward in half. It's going to do a couple of things. It's going to reduce the supply, and it's going to make it so I'm not going to run my miner unless I'm getting paid enough to justify all that hard work I did. I had to pay a lot of electricity to find that magic nonce.
Right.
By me doing that, I'm exchanging my electricity, my hardware, all of these things I'm paying for that money. And if nobody is willing to do that, then the network will fail. So you're just by operating the network, that's where a lot of the value comes from, is that in order to get me to even run it, if you want to participate, you've got to pay me to mine those blocks, and that's what's determining the value. So it's very much supply and demand oriented, but you're really just paying for compute.
Right. So basically what you're saying is, this is a bit scary to me, is that if the price of electricity went up so high that it was no longer economically worth your while mining, the whole currency collapses?
Right, it seems that way. There's one trick.
That is scary. That is scary,
right,
man.
That would be a broken system. Absolutely. It's a good observation too. And the reason why that doesn't happen is because there's a difficulty rating in there.
Okay.
And the blockchain manages this. So we're talking about Bitcoin. Even Ethereum, when it was proof of work, did this, but Ethereum's transitioned to a different technology. But for Bitcoin right now, what happens is that if it's keeping track of how many people are trying these hashes, how many people are working on it. I should say how much hashing power is really being done. And if the way it really tracks this is almost a heuristic. How fast did somebody solve the block?
Right.
Because it takes, the goal is 15 minutes. If it takes a half an hour, then the next block is going to reduce the difficulty so that more people can do it. So it's automatically scaling the difficulty, and it does that by changing those leading zeros on the hash.
Okay.
So if right now it's 4 zeros, and all of a sudden it was really hard to find that magic nonce, and it took us over 15 minutes, then the network will go, oh, that took too long, I'm going to change it so we only need 2 zeros. And now that next time somebody should be able to find that faster. Rochester. Now it's something like 20 zeros right now, so it's extremely hard to find it, and that's why you have millions of people around the world racing to find it, because it's extremely hard to find something that has a hash that starts with 20 zeros.
Do you really have millions of people? Because I thought most of the mining was done by these sort of large corporations, most of them all based in China, funnily enough. Everyone, I mean, they're using GPUs, they're using a ton of electricity, they're causing nothing but pollution problems. When's someone going to take action on this?
It's a very interesting topic, and we've been watching it pretty closely. A lot of this is actually driving people to use hydroelectric or solar because it's cheaper. Once they do that, they don't have to keep paying that bill. So we're seeing it's actually starting to influence things in a way that is good. And when we look at it, it is a very small amount of pollution by comparison to like industrial applications.
No,
now, it doesn't justify it. It's still a lot of added pollution, right? And I think that's the balance that we have to have. Now, when we look at a system like Ethereum, they've switched from proof of work, doing these hard math problems, lots of compute, lots of electricity, lots of heat generated. We're transitioning now into these proof of stake models. And the way that's done is instead of me doing a bunch of hard math problems and using compute, I can use the money I already have on the network, so my Ethereum, and I can use that and say, I'm gonna approve this transaction. And everyone around the world can see all the transactions. They can look at them and go, oh, he used proper transactions. I trust him. And I have to stake my Ethereum to do this. So I actually lock it away in a vault. And if I lie, then they'll take some of my Ethereum. So I'm financially incentivized to do the right thing, and if I lie, everyone can call me out, and then they can take some of my money. But this new model, proof of stake, uses a lot less electricity.
Obviously.
Yeah.
Do you think Bitcoin will change over to it?
I don't.
No?
I don't think
They'll
so.
keep on going with their proven model.
Yeah, I do think that they'll keep going with that.
I'm finding this absolutely fascinating, and I do hope the people out there are as well. Before we close up this show, and I'd love to have you back at the table so we can continue our talk, but there's just one other little topic. If I get $1 out of my wallet, I know that tomorrow it's going to be worth $1. It may be a few cents below if I want to cash it in against, say, a foreign currency, maybe a few cents above. It never varies that much. The only time it does vary is if a government gets involved. This happened in Britain back in the days of Harold Wilson, back in the 60s, where the pound got into real trouble. So Wilson devalued the pound. And if memory serves me well, he did it twice, which basically meant it changed all the exchange rates. Okay, so there is exceptions to what I'm saying. The trouble with something like a Bitcoin, interesting little side note on that. What ended up happening after Wilson devalued the pound was we ended up owing America more for their war effort help than before.
Wow. Yeah.
So the bill went up.
Right.
Anyway, so we know the dollar can change a little bit. We know the pound can change a little bit. We know the euro can change a little bit. But we've seen Bitcoin go all over the place. And of course, it was only a handful of months ago where the whole lot crashed. Why do people want to risk that? Because you're risking a hell of a lot of money.
Yeah, there's a lot of money involved. And to buy Bitcoin at $60,000, which is close to its peak, and now have it at about 20,
exactly,
you would have lost 66% of your investment.
Even Wells Fargo hasn't lost that amount of money for me.
Right, yeah, exactly. And, and it is really interesting to look at even stocks like Google right now. We're at about, I think, 180. They just recently split, and now it's trading at almost 90.
Yeah.
So, we're almost at a halving on really big trusted tech, and the volatility of a lot of the S&P 500 stocks are actually even comparable, if not worse. Most of them on average are worse than we're seeing with Ethereum and Bitcoin right now. So I think we're at a point where we're just coming to parity with the activity, the volatility, and the risk. But back to a very good point you made, why does it have value? And it's the same thing that with the US dollar, it's the same thing with the stocks. It's all about what people believe, that I can buy a house with this. Do you believe that? Yes, I do. But we believe in the dollar so much because we have a government and our country behind that. So that gives us a great deal of confidence. What is in Bitcoin? Well, we have the world behind that. And, so there's something interesting there, I think, that people around the world believe in it. And that's what's really driving it. But there is no direct thing. And you can't really take a US dollar to any hard asset and say, this is what it's worth. Houses are going up 10% a year. Yep. So they are devaluing that currency and they're printing more and more of it in just the same way. So we could almost start to look at Bitcoin, because it has a controlled supply, as a hedge against this constant inflation and constant money printing.
See, I would agree with you on that if I knew it was stable, but they proved it ain't.
Yeah.
Anything can happen. I mean, it's a bit like stocks. We all know that if you buy stock, you're taking a gamble.
Yeah.
That's the whole point. The thing is, though, is that stocks typically remain fairly flat. Hopefully on the rise, sometimes. Now, we've gone through a period, of course, after the COVID, we got the problems with inflation. We had the gas companies deciding they're going to rip everybody off. The thing is that with stock, it typically does stay about the same. But as you said earlier, Bitcoin, it can be up to $60,000 a coin, drop down to $20,000 a coin. Tomorrow, it might be worth $5,000. On the other hand, it could be worth 50.
Yeah, I think it goes back to the idea that this is a world currency.
A world currency.
A world currency, and that people trust it. They can run it themselves. It's very hard for a government to take it away from you.
Yeah.
They can block it, but when they block it on like a global firewall, like China was, I think, trying to do, people will VPN out through other means and then connect to the rest of the world, and they can transact. And so it becomes very difficult for anyone to stop, because there's no one location you block. It's anybody who's running one of these nodes. So people inside China, people outside China, as long as you can talk to them and connect to them through the internet, they can run the blockchain.
They can run the blockchains, and everything can carry on working as normal.
Exactly. So it's a very hard system to take down. And
I'm never going to be convinced this is good. Okay, I'll be honest with you.
No,
but mind you, I'm an old fart, so what do I know? At one time when you had a pound note, there was a piece of silver running through it, and that silver was worth £1. And that's what gave the money value. Yeah. Do you have any final words on this?
I really think blockchain is going to change the world. I don't know if it's cryptocurrencies are going to be involved. I think that we're going to see insurance companies transition to using blockchain. I think we're going to see hospitals, lineage tracking for humans, for animals, all done on blockchain, right? Supply chains. It's almost like a new internet, because each of these blockchains, we call them networks.
Yep.
So Bitcoin is a network, Ethereum is a network, and all those computers are just talking to each other in these areas. And it's so easy to build applications on this technology.
Right.
A little web interface that talks to the blockchain, and you can transact. You can send money. You don't need banks. You don't need third parties. You don't have to integrate all these advanced systems. You just point to one IP address of somebody who's running one of these nodes. You build a very simple web application, and you can either update the data for a supply chain, or you can transact currency. It just depends on what you want to do. And it's so easy to build that I could just see applications being built in the wild.
Just taking off.
Yes. Yeah. And that's what we're seeing right now, is it's happening, I think, just right now.
I'm guessing that banks use blockchain technology, especially banks that have all around the world branches.
Yeah.
So
they are.
It's
Absolutely.
really a technology that
we're seeing that right now.
We're not hearing a lot about it, because I think most people look at blockchain technology as being just cryptocurrency, whereas, as you've so very distinctly put it, no,
It's not.
It's everywhere.
Yeah. Yeah, that's right. And we are seeing the big banks start to use it. Moving their assets between their different locations in the world was very costly for them.
Oh, yes.
And I think JP Morgan already has an internal currency that they use. Nobody can transact it. It's a private network. But at night, when they're settling all the different accounts from around the world, they'll move it, and it's guaranteed. Nobody who works there can hack that system. Nobody can change the numbers. It's guaranteed just because of all these things that we've talked about. And they have all that right there. And so it just saves them a fortune on settling their transactions at night, and they just created it internally for themselves.
Right.
So,
well, that makes a lot of sense.
Yeah, it does.
It really does make a lot of sense. Nik, thank you so much for coming down here and totally confusing me.
You're welcome, Nigel. I was happy to do it.
You are a master at it, my friend.
Thank you, sir.
No, I found that really interesting. And we only scratched the surface.
Yeah, we could go deep.
Would you be willing to come back and talk a little bit more on this subject? Because I think there are other areas that I'd like to investigate, and I'm sure there are other areas that you'd like to talk about, things that we'd never even thought about before.
Yeah, I'd love to, yeah.
Nik,
I'd love talking
thank
about
you
this
so
stuff.
much for coming down here.
Nigel.
I don't know how confused you are out there in viewerland. I know I'm really confused now, but I understand the basics of it. So a central database, all these people talking to it, everyone verifying what everyone else is doing. So I guess that's a really good safety net. Anyway, thank you so much for watching the show. Don't forget to subscribe to our channel, and I will see you next time here at the table. I'm Nigel Aves, your host, signing off. Thank you so much. Bye-bye.